Alright class, and welcome back to another day of notes. This is day 3 of our current unit, which this current unit, as you can tell, the major focus is the periodic table, and more specifically, the focus is the atom. So today we're getting into the specific structure of the atom, and we're actually just going to start with another definition of matter. I know that matter, we originally learned this back in Unit 1, but now that we're learning the periodic table, we need to understand that everything on the periodic table is matter. And so we're going to give you kind of two definitions right now. The first definition is the same as what we had back whenever that was, Unit 1. So it's anything that has both mass and volume. So it's anything that basically consists of stuff and anything that takes up space. All right, it means it has both mass and volume. That's considered matter. Now, here's the second part that we're going to add to this unit. We need to understand that matter consists of atoms. And so we've learned a little bit about what an atom is throughout the course of this unit. Day 1, you focused just on the periodic table. Day 2, which was last class, you focused on a lot of the scientists who contributed to different parts of the protons, neutrons, electrons, and all of this stuff. Well, day 3, we're really focusing in on what we call the 3 subatomic particles. And there are 3 of them. You learned about these originally back in 6th grade. You just learned about them in 6th grade. And then in 8th grade science, they teach you a little bit of how to count them. So we're going to learn that, plus a few other things with protons, neutrons, and electrons. So the first thing we'll go over here is just the symbol of each one. The symbol of each of these is the first letter of them. And then often what you'll also see is they'll also put the charge in there with it. So because protons are positive, you'll see a P with a little superscript plus symbol. For neutrons, they're neutral. So 0 is a neutral number, so you'll see N with a little superscript 0. And then same thing with the E, except those are negative, so you'll see a minus sign. This part is crucial, the location of them. This is crucial for us to understand, and you can see the picture down below here. But the only thing that's in the nucleus, which again, the nucleus is the middle, kind of like in biology, you had a nucleus of a cell, and that was located typically in the middle of a cell. The only things located inside the nucleus are the protons and neutrons. So protons are in the nucleus. You could even write in the, if you want to. For neutrons, also in the nucleus. All right, this is crucial for us to understand because if we do not understand that electrons are not in the nucleus, we'll get a lot of these questions wrong. So for that, we call this the electron cloud, and that's what Schrodinger came up with, which you learned at the end of day 2. He was the final scientist that kind of contributed to that. And we call these rings out here, another word for them is the electron cloud. But electrons are located on the outside. Definitely not in the nucleus, though. All right. The electrical charge, we know that protons are positive. Electrons are negative. Okay, leaving neutrons in the middle to be neutral. I will tell you, it's very surprising how many kids miss this on the tests and quizzes that we take. But when we ask questions about what the charge is, a lot of people see neutron and they see the letter N and they assume negative. Not so fast, my friend. Okay, neutrons. Look at the first 4 letters there, or 5 letters even. Neutral. Neutrons, neutral. Okay. Now, for the last part, and this you may not have learned in 8th grade, so this might be new for you, but when we talk about the mass of these subatomic particles, electrons have no mass. Technically, that's their mass, 0.000005. With that only being one sig fig and it being way back here, we're just going to call that 0. So electrons have no mass. Their mass is so small, in other words, that it does not contribute to the mass of the atom. The mass of the atom is contained inside the nucleus, and each proton and each neutron count as 1. So we'll say that the mass of this is 1 each. So if you had to tell me the mass of this particular atom, you would add up the protons plus the neutrons, and the mass would be 12. Okay? You're going to learn how to do that a little bit down here later when we get to mass number. But let's start by talking about atomic number, guys. You will find on periodic tables that they will give you all the information you need to know. And here's specifically what the atomic number means. The atomic number is the number of protons. So if I asked you an element, you could actually identify that atom for me. It helps identify an atom of a particular element. It also determines an element's location on the periodic table. And let me give you an example, guys. Let's look at our periodic tables. And if I asked you which element had 7 protons, hopefully you could look at your periodic table and you could look at these atomic numbers, which are the numbers at the top of the particular periodic table we gave y'all. It's at the top. So 7 protons, nitrogen. All right. This particular element, hopefully it makes sense why that's carbon, guys. How many protons did carbon have here? It had 6 protons, which, if you look, 6 matches up with carbon perfectly. So that's kind of how that works a little bit with the periodic table. We'll talk about mass number here in just a second, but here's something that I need us to understand. If an atom is neutral, okay, neutral means that the overall charge is 0. So think about this. If I had 6 protons, in order to cancel out the charge of those 6 protons, what else would I need 6 of? Well, we would need 6 electrons to cancel that out. So what I'm getting at here is that protons will be equal to electrons. Because, and the idea here being that we want to cancel them out so that we end up with a neutral number. All right. You'll see that when we get to some of the problems on the homework page for today. But let's go ahead and do mass number now. So the mass number we learned up here, I kind of mentioned it, but it represents the sum of 2 things. Okay, it's the sum of protons plus neutrons in the nucleus. Okay. So, what if I gave you the mass of something? What if I said, hey guys, this atom has a mass of 14, okay? We know that 14 would equal the number of protons plus neutrons, right? Well, what if I told you that it had 5 protons? Could you figure out how many neutrons that would be? I could turn it into a little algebra question, but hopefully you could tell me that by subtracting 4 from 5, we can get the neutrons as 9. So the number of neutrons is equal to this, which is our mass number minus, so mass number minus the protons. Okay? So that's how we're going to figure that out. Now, there are technically, guys, there's technically 2 ways that we can write these out. And I'll give you an example of both. Just the basic name of it, as well as what I'll put over here called the nuclear symbol. So let's pick a different element here. Let's pick, let's go with sodium. Okay, sodium is Na on the periodic table. So if I was to do the nuclear symbol, you would have Na as well as a couple numbers here. Let's say 24 over 11. Well, 11, guys, identifies how many protons it has. Okay. The other way to do it would be just by putting the name sodium followed by the mass number, which was 24. So, like I said, there's 2 ways to do this. You can put the name of it or the nuclear symbol. If I skip ahead to today's homework problems, I'll show you kind of what that looks like. So on today's homework, guys, you've got about 6 questions to work out, and really you're just filling out different information. Right here, this says symbol. More specifically, guys, that's going to be our nuclear symbol. But these are the types of questions that you'll get. So you'll have to be able to take something like this and identify what each part is. So let's start right here with that 24. That is our mass number. And so from that, I could figure out how many protons, neutrons, and electrons this particular element has. Okay? We can do it right here because this is the same thing. That top number is also the mass number. The bottom number is our atomic number. Okay? So if you do it this way, you only have to put one number. If you do it this way, you have to put both numbers. But either way, we can figure out how many protons this has, right? For protons, we look at the periodic table. And for Na, it's number 11. So this has 11 protons. All right. Well, if we know the protons, we also know the electrons. That's always the same. So we'd also have 11 electrons. And so the most difficult part, guys, usually is finding the neutrons. But if you know the mass number and the atomic number, you just subtract. Because if there's 13, think about that, guys. 11 plus 13 equals 24. So 24 minus 11 is 13. That's how you're going to work those problems out in just a little bit. So we can go ahead and skip to the next page, guys. And we're actually missing some bullet points, but every atom is going to contain the following. There should be a total of 5 bullet points here. I think these ones got left off. But every atom contains a nucleus. Easy to recognize, right? The nucleus is in the middle of the atom. Every element also contains protons and neutrons, which are located inside the nucleus. Then we have electrons, which are located in what we refer to as the electron cloud, or another term for that is energy levels. So when we draw them like this, you can tell that each energy level contains a different number of electrons. All right, so a few more things to take note of or to review before we get into the actual homework questions would be that the number of electrons is equal to the number of protons. Also take note that the atomic number represents the number of protons. So if you know the atomic number, you know protons and electrons, guys. The mass number is equal to the number of protons plus neutrons. And so we can answer any type of question that we have here. Hydrogen, oxygen, or nitrogen. We went ahead and put a picture of oxygen and nitrogen on here for you, but hydrogen, guys, is literally the first element on the periodic table. So if I was to draw hydrogen for you, you'd have hydrogen there, and that would be your nucleus. Kind of do it like that. There would literally only be one ring around it. And so inside here, you would have one proton. The mass of hydrogen, technically there are 3 isotopes. You could have hydrogen 1, hydrogen 2, or hydrogen 3, but for the sake of this, let's go with the most common isotope, which is hydrogen 1. So if hydrogen has a mass of 1, well, it already had 1 proton, which means it has 0 neutrons. Energy levels, it only has 1 energy level, and there is 1 electron floating around the outside of it. So, I know that's probably not the best example to do, but let's do oxygen together, and then I'll have you do nitrogen on your own as part of your homework. You will also have the chart on the next page as homework. So we'll check all these next class, but let's take a look at oxygen. Okay, how many protons does oxygen have? Well, the picture didn't look great, but you can tell that oxygen from the periodic table has 8 protons. Okay. The 0, I'm not 100% sure what this was supposed to do, but let's pretend like it's oxygen's most common isotope, which is oxygen 16. Well, if it has 16 as the mass, what's 16 minus 8? Well, that's 8. Okay, how many energy levels does this have? Here's the first energy level, right there. Here's the second energy level. We have 2 rings around it. So we would have 2 energy levels with a total of, it should add up to 8. 1, 2, and then we'll go around starting from the top. 3, 4, 5, 6, 7, 8. So yes, a total of 8 electrons. All right, if y'all would, guys, please do nitrogen for homework. And we're going to continue today by talking over the last concept for day 3 notes, which is isotopes. And isotopes, guys, it's really easy when you get to see a picture like this. And we will have some quiz questions like this, but you'll notice that an isotope is, first part of the definition, same element. Okay? An isotope is the same element that has different masses. So you'll notice lithium, 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 it always has 3 protons. But if you look at the part that changed, the mass changed. So right here our mass was 6, then our mass was 7, then our mass was 8. If you look at lithium on the periodic table, Miss Scoggins is actually going to teach this next class, but if you see how there's typically it's either 6, 7, or 8, This 6.9 kind of makes sense when you see that. And so next class, Miss Goggins is going to teach us how to actually calculate the average atomic mass. But for today, it's nice and easy. We get these nice whole numbers to work with. So if you were asked about the number of protons on these questions, the protons would be 3 every time. Okay? Those always have 3 protons. Now, what if you were asked about the neutrons? That would be different for each of these isotopes. Okay? 6 minus 3. That would give me 3 neutrons. 7 minus your 3 protons would give us 4 neutrons. And for the final one, 8 minus 3 would give us a total of 5 neutrons. So you can tell you've got to be careful that these numbers are correct to get those questions down here. Okay, if you want to get those correct, you got to pay close attention. So what does that mean for, I gave you just another hypothetical question. You'll notice that both of these are silver because an isotope has the same element, but what's different? The mass. So silver always has the same number of protons, right? So how many protons does it have? Whatever number I come up with, it should be the same for both of these. So let's find silver on the periodic table. And silver is right here. It's number 47. So that means it has 47 protons. And electrons would also be 47. Okay, so then how about the neutrons? Well, if the mass right here is 107, I need to subtract 47, which was the protons, to get my neutrons as 60. Same thing here with the 109. 109 is how many protons and neutrons are in it. So to get just neutrons, I have to subtract the 47 protons that we had to figure out this. That's going to be 62. Okay, so 62 neutrons. So why are isotopes the same? Because they have the same number of protons, okay, which means that it's the same element. So, why do isotopes have different mass numbers? What made these mass numbers different? Boom, you can see it right there. Because they have a different number of neutrons. So, in summary, atomic number equals the number of protons. Mass number is equal to the number of protons plus the number of neutrons. And then last but not least, in a neutral atom, the number of protons will equal the number of electrons. Now, you're going to use all this that we learned today to work out the following homework questions. You've got one multiple choice down at the bottom, and then you have this table that has, it's just each question gives you a different piece of the puzzle, so to speak. And so it's your job to take, I'll do a couple of these with y'all. I'll do number 1 and number 2 with y'all, and then y'all can do the rest of these on your own for homework, and we'll talk about this next class. But carbon 14, all right? Carbon 14, if you don't want to start with the nuclear symbol, I don't blame you. I usually like to start with atomic number. And for carbon, the atomic number is 6. As you can see right there, carbon has an atomic number of 6, which means it also has 6 protons. Now, protons is going to equal electrons, so this would also be 6. And then for neutrons, we have to take the mass number. Well, I don't have the mass number, but I do. It told me that carbon's mass number for this particular problem is 14. So now I can subtract, because I know that mass number is equal to protons plus neutrons. So this would have to be 8. 6 plus 8 equals 14. Okay? Now, the nuclear symbol, I'm supposed to put the mass number on top of the atomic number, followed by the atomic symbol. Okay? So we did number 1 there. Now, it's going to take you a while to get used to these, and we'll have some more practice for you next class before our quiz. But the quiz on this is not until 2 classes from now. So you've got a little bit of time to get this down. But let's work out one of these now. Now we're working it out backwards. If you can see, I did not give you the element or anything. I gave you the atomic number, which is going to tell me protons. Protons, since they're equal to electrons, I know that also. And then we know that mass number is going to be equal to protons plus neutrons. So 10 plus 12 is going to give me a mass of 22. Now, I've got to bust out the periodic table to figure out what element this is. So my question for you, and this is always the biggest thing that kids mess up, when you look up on the periodic table, are you supposed to look up the atomic number or the mass number? Which one determines the element? Okay? It's the atomic number. So you need to look up number 10 on the periodic table. Okay? And don't make the mistake at looking like at the decimal number 10. No, we're looking at the whole number. Number 10 is Ne, which is neon. So this element right here is neon. And then if you forget what you're supposed to put after, just look at the previous question. This 14, was that my atomic number or my mass number? Okay, it was my mass number, which means right here my mass number was 22. So it's neon 22. And then another thing that can be helpful when you get to this part of the question, if you're deciding to put 10 over 22 or 22 over 10, the bigger number always goes on top. So hopefully that helps. But it was 22 over 10 Ne. All right, guys. Now that you've seen both types of questions, I want you to finish class by working on the rest of these. If you have questions, please let your teacher know before you leave. Other than that, good job today, and we will see y'all on the next one.